Hello students, welcome to my class. Today we will do atomic structure, okay? And here in this video I will elucidate the properties of all the constituents of an atom. I will tell you what is octet rule, I will tell you what is electronic configuration, and most importantly I will stick to your syllabus. And for chemical bonding I will upload a separate video. So in this video exclusively only the atomic structure will be discussed. And I know that the chapter is not difficult because you have already done it last year, and most of you have proper concept also, but anyway I am going to do it once again, and I will be also telling you about the questions that you can get in the board paper as well as for the term. So please like, share and subscribe my channel, and watch the video properly. You will like it and you will understand also because it is simple. Okay, so atomic structure, right? The topics that we will do today are subatomic particles, nucleus, nucleons, orbit or shell, atomic number, mass number, electronic configuration, valency, isotopes and isobars. Okay, so one by one we will take all the topics, right? So first of all, let me tell you that John Dalton's postulates had told us that atom is indivisible. And it cannot be created, it cannot be destroyed, it is similar. But the modern theory was there that told us that atom is not indivisible. There are fundamental particles, we will do that. We will also show how atoms can be, we prove it because they can combine and new things can be formed. And we will also show that the isotopes are there, which will explain the rest of the postulates of John Dalton and give a clear idea of what is an atom. So first of all, an atom. It's the smallest particle of an element that may or may not exist independently. So I repeat myself, whenever there are definitions, please stick to your text, okay? And learn it correctly, because definitions, if you are not writing it correctly, you don't get marks. Right? So it's the smallest particle of an element that may exist or may not exist. The fundamental particles of an atom are electrons, protons and neutrons. The electrons are negatively charged, the protons are positively charged, and the neutrons have got no charge. So we will talk more about this, but before that, what's an element? An element is a pure substance that can neither be formed nor be decomposed. Like if you have, I have taken the example of carbon, any element you can take. Like suppose I have taken carbon, it cannot be split. You cannot break it down to any different thing. It is carbon. So the smallest particle is also carbon. So it's a pure substance which cannot be formed or neither can it be decomposed. Actually, I was discussing about it just now, that John Dalton has stated that atom is indivisible, but we know now because Sir J.J. Thomson discovered the negatively charged particles called electrons. E. Goldstein discovered the positively charged particles called protons, and James Chadwick discovered neutrons. Okay, so we are not going to the method of the discharge tube and all that, because that is not there in your syllabus, and I said I will be sticking to the syllabus. So straight away the structure of atom. Okay, so the next. Now about the subatomic particles, we will know more about it. An electron is a subatomic particle which has a unit negative charge. And how much of unit negative charge? It is minus 1.602 into 10 to the power of minus 19 coulombs. And the mass, which is equal to 9.108 into 10 to the power of minus 31 kg, which is very little, very, very less. And it can be therefore represented by E superscript 0, which denotes mass, subscript minus 1, which denotes the charge. Also, E superscript minus can be symbolized for electron. Next, proton. It's a subatomic particle having a unit positive charge of value, see, same, 1.602 into 10 power of minus 19 coulombs. This is minus and this is plus, that's the difference. And the mass is 1.672 into 10 power of minus 24 gram, more than electron. And it can be represented by capital H, hydrogen, 1 and 1, atomic mass 1 and charge 1, or P to the power plus, that is superscript plus, proton with a positive charge. A neutron, we all know, is a subatomic particle with no charge and mass which is almost equal to the mass of a proton. So both the masses of neutrons and protons are nearly equal. It can be denoted by superscript 1, mass, subscript 0, no charge, so it can be represented by N. The protons and neutrons are collectively known as nucleons, and they are found in the central part or the nucleus of the atom. They present at the center of the atom, which is known as the nucleus, and the protons and neutrons are collectively known as the nucleons, and the electrons are found outside the nucleus. Okay, so the next, about the structure of the atom. Atoms are electrically neutral, that means atom will not have any charge. Why? It is known that number of protons are always equal to the number of electrons. Like the number of protons present in the nucleus of the atom is always equal to the number of electrons outside the nucleus. And this directly implies that the total number of positive charge is equal to the total number of negative charges. So they cancel each other, thus the atom is electrically neutral. We talk about nucleus, which is the center of the atom. It is a massive, positively charged center of the atom. Why? Because this is at the center of the atom. It's positively charged. Why? Because in the nucleus both protons and neutrons are present, but protons are positively charged, neutrons have got no charge. So the nucleus is also positively charged and massive. Why massive? Because the sum of the protons and neutrons makes the mass of the nucleus with a very small size. This was discovered by Lord Rutherford. There was a plum pudding model also. All that is not discussed here. As I told, I am sticking to the syllabus directly as given. So discovered by Lord Rutherford. Thus, an atom is built up of 3 subatomic particles, electrons, protons and neutrons. The structural part of the atom are nucleus, that is the center part, and the empty space around the nucleus, in which there are imaginary parts which are known as orbit or shells. Now, you all know planets revolve around the sun on what? Orbit. Do you actually have any path? No. Similarly, electrons also go around the nucleus in their own path. These are imaginary paths, but they are known as shells. There are many shells. We name it also. We know also how many electrons are where. I'll discuss it later. So, protons and neutrons are found in the nucleus and electrons revolve around the nucleus in the orbit. Next. Now, this is important. Okay. Atomic number represented by capital Z. Actually, each atom of an element has got its own number of protons in the nucleus. No two atoms of no two different elements will have the same number of protons. It is a characteristic number of protons which are present in the nucleus, and this is the number which distinguishes the atom from the other elements. Okay, so atomic number is the characteristic number of protons present in the nucleus which distinguishes it from the atoms of other elements. Though the number of protons and number of electrons are same, but we cannot say that the atomic number is equal to the number of electrons, because I will tell you, electrons which are present in the valence shell, all that I will discuss, may gain or lose, which you will understand in the later half of this video. But for right now, please children, do not write that atomic number is equal to the number of electrons. You are going to get it wrong. Please stick to this definition given in your text. It is the number of protons present in the nucleus. It is the inherent property, so please don't change the definition. Okay, then mass number, which is denoted by capital A, it is the sum of the nucleons, that is the total number of protons and neutrons present in the nucleus of the atom. Now representation, how do you represent it? It is capital X, superscript A, subscript Z, where X is the symbol of the element. Whichever element we are talking about, we write the symbol. The superscript capital A is the mass number. The subscript capital Z is the atomic number. Example, this, where C denotes carbon atom, 12 is the mass number, which is number of protons plus number of protons, which is 12. 6 is the atomic number, which is number of protons, same as number of electrons, 6. So, when you know number of protons, you know number of neutrons, subtract from the mass number. Like I have shown it here, for a chlorine atom, 35 and 17, atomic mass 35, atomic number 17, number of electrons 17, number of protons 17, so number of neutrons will be A minus B, that is 35 minus 17 is 18. You are definitely going to get questions on this type, on the maybe of making, a teacher will make a column out of it and she will write capital X and you have to name and identify the element. She will be giving you A or Z, you have to find the rest of electrons, protons and neutrons, or she'll give you electrons and neutrons, you have to fill rest of the atomic mass and mass number or number of protons. All that types of question will be probably there in your text for practice, so just check. Next, now comes the electronic configuration which I was talking to you just now. Now when we know that the electrons are present outside the nucleus in the orbit, we should know how. This distribution of electrons into different shells was given to us by a scheme given by the scientists Boyle and Bury, and therefore known as Bohr-Bury scheme, and is given by 2n square, where this n now denotes the number of shell, right? So 2n square. So for the first shell, which is the K shell, it is 2 into 1 square, so 2 electrons. The second shell, that is the L shell, is 2 into 2 square, that is 8 electrons. The third shell, that is the N shell, is 2 into 3 square, that is 18 electrons. And the fourth shell, that is the N shell, is 2 into 4 square, so 32 electrons. Therefore, we now know that the first shell can accommodate only 2 electrons. The second shell can accommodate only 8 electrons. The third shell 18 and the fourth shell 32. But we should also know this, that the N shell can fill 8 electrons, though the capacity is 18, because after getting 8 electrons, the element becomes stable. So it is not that it is not going to take the rest of the 18. It is just showing that when the element is stable, it is when the outermost shell has got 8 electrons in its outermost shell, valence shell or valence electrons. Now, about that SPDF, I will not be talking to you right now because children, you will get confused. Just understand this much now, because that SPDF, teaching S shell, P subshell, D subshell, F subshell will be difficult for you to understand. To actually tell you the redistribution of 18 and 32 into it. Therefore, as in for now, just remember that the first shell has got 2 electrons, the second shell 8 electrons, third onwards, though the capacity is 18, but it can fill 8 electrons. Just simple reason that they become stable after it. Okay, next. Okay, now after explaining that how many electrons, protons and neutrons are there in each atom of an element, what is the mass number, what is the atomic number, what is the electronic configuration, that is distribution of the electrons in the shell. We can now ask you to practice drawing the structure of all the atoms of atomic number 1 to 20. Please take it seriously. It is there, it will be there in the question paper where you have to literally draw and show the atom's structure. I have taken 2 for you here. The rest, please try out. You may take the help of your text also. So here I have taken for magnesium. So this symbolizes that the atomic number is 12, the mass number is 24. So the electronic configuration is 2H2, that is K shell has got 2 electrons, L shell 8 electrons and M shell has got 2 electrons. Z means atomic number 12, so number of proton is 12, number of electron is 12. A is 24, so number of neutron 24 minus 12 is also 12. This I showed you here, subtraction. Okay. For potassium, Z19, so number of proton 19, number of electrons 19, A 29, so 29 minus 19, N is 20. Sorry, this is 39, okay, this is 39, wrongly printed. So 39 minus 90 is 20. So see, the electronic configuration is 2881, K shell, L shell, N shell and 1. So this is how you can draw. Keep one thing in mind, children, when you put the electrons, please pair them and keep. Please, second shell, third shell, pair the electrons and keep. You cannot distribute it all around in the orbit. Take care of it. Okay, now we were talking about valency. When the term valence comes, it means the outermost. If it is the outermost shell, it is a valence shell. If it is talking about the electrons in the valence shell, these are valence electrons. So I have written it down over here for you. The outermost shell is the valence shell and the electrons present are valence electrons. So actually, when we are talking about chemical property of an element, it is always decided by the valence electrons, because it is only the valence electrons which participate in the chemical reaction. The valence electrons either have a tendency to lose them or to gain some more electrons. So the participating electrons are always valence electrons. Therefore, the chemical properties of the elements are decided by the valence electrons. So the valence electrons participate, and thereby whenever the number of valence electrons are same, the chemical properties of those elements are also similar. If there are 3 electrons in the outermost orbit of one element and there are 3 electrons in the outermost orbit of another element, the 2 elements will have many similar chemical properties, as in we are talking about the chemical reactions. Now, if there are 1, 2 or 3 valence electrons, then they are metals. They will always have a tendency to lose those electrons and form positively charged ions called cations. If there are 4, 5, 6 or 7 valence electrons, they are non-metals and they will always have a tendency to gain electrons and convert into anions. Okay, so we have ionic equations like this. I have taken 2 examples. Children, there are many in your text. You should practice this. One ionic equation question is definitely there in your question paper. Okay, take it seriously. So sodium, atomic number 11, electronic configuration 281, 1 electron in the outermost orbit. It's a metal. So it will have a tendency to lose this 1 electron and become 2,8. That means stable. It will try to attain stability. How? By stable electronic configuration. So cation, Na+. Similarly, chlorine, atomic number 17, electronic configuration 287. It will gain 1 electron and now become Cl-, anion, 288, stable electronic configuration. It's a good oxidizing agent, whereas metals are good reducing agent. Please remember, Metals are always good reducing agent and non-metals are always good oxidizing agents. Next. Now what about elements with 8 valence electrons? Because I was just talking about getting 8 and it is stable, getting 8 and it is stable, okay? So what about the elements with 8 valence electrons or just 2 electrons in the first shell? They cannot gain or lose, therefore they are chemically inactive. I was just talking to you that the valence electrons either have a tendency to gain them or lose them. Therefore, they chemically react. But the elements with 8 electrons in the valence shell or 2 electrons if it is only the first shell, they are chemically inactive. They don't react. Therefore, they are known as noble gases or inert gases. That is indirectly meaning what? That all chemically active atoms will have incomplete valence shell. They will have less than 8 electrons. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3 metals, 4, 5, 6, 7 non-metals. 8 will be inert or noble. Please try to understand this. Okay, next we come to valency. It is the combining capacity of an element. You know it very well. It is equal to the number of electrons that take part in the chemical reaction. So, if there are 2 electrons participating, valency is 2. If there are 3, the valency is 3. So, it depends upon that. How? If the valence electrons are 1, 2 and 3, they have a tendency to lose them. So, their valency is directly 1, 2 or 3. If there is 1 electron in the outermost orbit, valency is 1. Like sodium has got 1 electron in the outermost orbit, the valency is 1. Similarly, if there are 2 electrons, the valency is 2. Magnesium, 2 electrons, valency 2. Aluminium, 3 electrons in the outermost orbit, valency will be 3. But if the valence electrons are 4, 5, 6 or 7, the valency will be 4, 3, 2 or 1. How? We subtract it from 8. 8 minus 4 is 4, 8 minus 5 is 3, 8 minus 6 is 2, 8 minus 7 is 1. So, we subtract minus 8. Okay. So, all the elements except inert gases combine. Why? I discussed just now, in order to attain a stable configuration, that is octet rule or duplet rule. Duplet, that is having 2 electrons in the first shell. Octet is 8 electrons in the valence shell. We are towards the end of the chapter where we talk about isotopes and isobars. Children, there are different properties of isotopes and isobars. Uses of isotopes and isobars given in your text. Please learn them. There are many more examples also. I have not written down all. Please learn them. But I'll just tell you what this is. Isotopes are atoms of same elements. Okay. They are same elements. That means they have same atomic number but different mass number. And how do you differ the mass number? By different number of neutrons. Like protium, deuterium and tritium. Hydrogen, H1, H2, H3, all will have atomic number 1. So, number of electrons 1, 1, 1, number of protons 1, 1, 1, number of neutrons 0, 1 and 2. So, protium, deuterium and tritium, same atomic number, different mass numbers, but same element. Okay, they have same number of electrons in the outermost orbit, so they will have similar chemical properties, but since the nucleons are different, they will have different physical properties. What about isobars? They are atoms of different elements or different atomic number but same mass number, like argon and calcium. Atomic number 18, atomic number 20, but mass number 40 and 40. If they have different atomic numbers, so definitely different chemical properties, and they have different number of protons, so different physical properties as well. Okay. So, I have actually discussed all the important topics that are there in this chapter and tried to explain the thing properly, and I am sure you have understood, but you need a lot of practice and lot of learning, as in for definitions, for the properties, for the structures, for atomic numbers and so on.